All right, guys. Shh. We can talk more about Anders Carlson later. Okay, so the first three formulas on the sheet are mostly used in the medical field. Has anybody been, besides Rowan, has anybody been to the hospital lately? Okay, have you gotten an IV?
Yeah. Yep.
Okay, so anytime you're given a medicine, especially in its liquid form at the hospital or from the doctor or from the pharmacy, it's usually given to you in a concentration that's 1 of the percents. So the most commonly used one, for example, like if you need to be hydrated, they will give you a saline solution because it is the same concentration as what's supposed to be in your blood, and that will rehydrate your blood cells. And so I'm just going to erase this here. The concept, you don't have to write this down. It's sometimes helpful for me to write down what I'm telling you. They use a 0.9% sodium chloride solution to get you hydrated. So this is a weight per volume percent. And so the medical field is the one that uses mostly these first 3 types of calculating solutions. So we would use number 1 if you had a solid or a thicker liquid and a thicker liquid. So in compounding medicines, if a pharmacist has to use make an ointment, he or she would use that first formula to make an ointment. The second formula would be used if you're mixing 2 solutions together. So if you had to mix a, oh golly, I can't even think of one from medicine. I can only think of ones from chemistry. Okay, I'm going to skip that one. But the third one is the one where you would be mixing a solid into a liquid, mostly water. So if you have to make a sugar solution or a salt solution or any other kind of where you're taking a solid and putting it in water, you would use solution formula number 3 to help you calculate that. So the first 3 are mostly confined to the medical industry. We don't very much use percent solutions in the lab. In chemistry, we have our own way of calculating and measuring solution concentrations. And the most common way that we will use is called molarity, and that's solution calculation number 4 on your sheet. So this is the one that you're going to have to, in order to be successful here, we'll have to know how to do the best. All right, so just thinking about this, you don't have to raise your hand or out yourself in any way, especially not to me. Are any of you thinking, so don't, this is a rhetorical question. Are any of you thinking about AP chemistry? If you are, then this is something that you have to just absolutely know, not something you look up on a formula sheet. It's something that has to be a part of your life now, from now until the end of days. For the rest of us though, we will always have our purple sheet and we'll be able to use it and it'll be fine. But that's how important it is for us as chemists. Okay, so molarity is abbreviated capital M. And its formula is moles of your solute divided by liters of solution. But normally we abbreviate this as just capital M equals moles per liter. So every time you're writing this formula down in the problems where you have to solve for molarity, you don't need to write moles solute. You can just write moles and then liters, and that's fine. Okay, so this is nice if we're looking for molarity, if we're looking for capital M, but what if we want to know about the other variables in the equation? So let's solve our algebra. In order to find moles, we'll do liters times molarity. And in order to find liters, remember my algebra trick? You can just switch L and M. So it'll be moles divided by big M. So if you have those algebra sheets written on the back of your pink or purple sheet, you can fill that in now for equation 4. the copper in hydrochloric acid is looking pretty nice. Isn't this lovely?
Solid.
Oh yeah. Oh, there's nothing juicy about this anymore. The water has all evaporated, but there's a little bit of juice trapped in there. It's like a blizzard. You can see the crystals on the bottom of this, and it's actually pretty neat. So I definitely ruined this beaker, but worth it. This one is still juicy, and there's still a bit of a penny in here, but this is actually pretty interesting. If you want to come and look at this later, you can see that the penny has holes in it, which I think is pretty. I don't think any more is going to dissolve or react. I think that just so much water has evaporated out of here. Well, we'll see. We'll see what that does. But isn't that lovely? Okay, so let's do some problems that involve this formula. There are a lot on here about molarity. Who was that?
Cord, I think this is engineering syllabus.
He is a special friend. I always like to see who is actually having their parents sign the syllabus and who's signing it themselves.
My mom's good at forging. My mom signed it.
I actually give them to my mom.
I mean, I obviously don't
The
care.
signature's too hard to actually try to copy. I don't understand it.
Jake signed my. Oh, I probably should put this in the recording. Jake signed my name for his science thing, and then he snaps me and he's like, "Mom, don't blow my cover. I forged your name," and I'm like, "Dude, I'm right here."
I said you work here.
What the heck? And then I was kind of like, I want to see how bad it was because I'm sure it wasn't good. And I was like, okay, if he asks me, I'll just say I signed left-handed. What the heck?
I was at dad's good.
Okay, so this is number 5 on your homework. It says to calculate the molarity of a solution that contains 2.5 mole of KNO3 dissolved in 5 liters of solution. Okay, so it says to calculate the molarity. So that means that big M is what question mark is. So a lot of times I'll wait till the end of my data table to write question mark, but here the first words say to calculate the molarity, so I'm okay writing that down. And then it tells me that I've got 2.50 moles. So that's what equals moles. And then again, 5 liters of solution. So that's my big L. Okay, so that's step 1. That's the data table step. Step 2 is to copy a formula down from my purple sheet. Well, I'm looking at these 3 variables here, and I know that the only formula on my purple sheet that has all 3 of those variables is number 4. So I'm going to write that down. Now I need to check. Have I solved for question mark? Yes. So last step is to just put these numbers in. So then let me ask, is it wrong if you put numbers in without the label? It is, because a number can't have meaning unless it has that label after it. And so don't let yourself get into the lazy person habit of not writing those units there. It'll only make your life disastrous as you progress. And it's really not that hard. Tedious, yes. Difficult, no. Okay, so 2.5 divided by 5 is, how many significant figures should we have? We should have 3. There are 3 here, 3 here, 3 here. And then what's my unit? Big M. And that's your answer. Now that's pretty easy, right? All right, let's try to find something that's a little bit more complicated. Oh, let's do number 6. Number 6 wants us to find out how many moles of NaCl are present in 100 milliliters of 0.125 molar solution. So when you read that as like an adjective, when you read capital M as an adjective, it's called molar, like your teeth. Okay, so here it says how many moles are present in 100 milliliters of 0.125 molar. Okay, so it's pretty easy for me to know what the variable is for that last one because it says what it is. But there's a bit of a problem there with the volume. Can anybody see what the problem is? Logan? And what should it be in? Yeah. Okay, so I want you to write this really big, maybe in a different color, maybe in a way that will like hit you in the face whenever you need to use this. I would say that of the mistakes, in all of the years that I've graded a homework like this is the by far most common mistake, and it has nothing to do with this. It has to do with unit conversions and the metric system. 1,000 milliliters equals 1 liter. There are more milliliters than liters. Okay, so many of you have drinks cups with you. Okay, so Connor, it looks like that maybe is like a 20 ounce. Nista, is yours a 20, maybe a 20 ounce? Maybe 6. Oh, wow. Ooh, that's a lot for that small of a container. That's a 32. Oh, okay. See, spaces are bad for me. So a 32 ounce is about a liter. 34 ounces make a liter, or like a little bit more than 34 ounces. So if you think to yourself, I'm carrying around a liter when I have my drinks cup, or for you ladies who are drinking out of your straw cups, those are probably 40 ounces, right? So over a liter. You would never think to yourself, oh, 100 milliliters is 10,000 liters, because that would be 10,000 of them cups. Like, that's, think about that in your mind to think, is this logical or not? Because if you're going to lose points, it's going to be here. And if you do it once, you're probably going to do it throughout your homework, and it's a snowball. Okay, so to get from milliliters to liters, you're going to divide by 1,000. So that means then that you should have 0.1 of a liter. 100 milliliters is less than what's in this beaker. Oh wait, no, this is 50 milliliters. I read it wrong. I'll fill it back up. There's concentrated acid in here, and putting water in it is like not what the dumb thing, so I'm just trying to be careful. I'm not kill myself. Okay, so this is 100 milliliters. It's not logical for this to be even close to a full like drinks container, because this is like a small amount. Like you could drink this, we wouldn't, because we would never do this in the lab, but you could drink this down in maybe a couple of like swigs. You guys know that there is this thing called a shot. It's like it's a liquid quantity, and we would never like take a shot of anything forbidden, like maybe Hawaiian punch. A shot is about 30 milliliters. So you could and it's like really like about a mouthful. So you could take that down in a couple of swallows, which means that we should have a small amount for the liter. I'm kind of like beating this dead horse because it's the most common mistake I see. Gentlemen, you gotta stop talking. All right, so I'm gonna write my formula down. I'm gonna write my molarity formula. But is this one solved for what I need? It's not. So if I know my algebra, I really don't need to look at my formula sheet, and then maybe I didn't even write anything on the back. But if my algebra is not friends with me, then I'm just going to see that I'm gonna choose this formula to begin with. So if you don't choose to write this down, I won't take points off. But you have to at least write this formula down before you put numbers into it. Okay, and now it's just a matter of putting your numbers in. And so for an answer, you should get 0.0125. Oops. And how many significant figures should you have?
3.
And that's what we have. What should be our unit? If you're confused about how to figure out what the unit should be, just go back to your formula and look at what you solved for. And that should be able to tell you, should give you a good clue. Okay, how are we doing? Thumbs up, thumbs down, thumbs medium? Okay, good. Let's make it more complicated. Let's ruin some lives here today. Connor is afraid to use his mind.
I need a mind to use first.
I knew you were going to say that. Okay, number 7. How many grams of glucose are present in 1.5 liters of 0.400 molar solution? Okay.
Time to go home.
All right, so I've got grams equals question mark. And then I've got 1.50 liters, so that means that's my L, right? Do I need to do any converting here? Nope, not yet. And then it tells me that I've got a 0.400 molar solution, so then that's my big M. All right, so look on your purple sheet and tell me which formula we should use. You want to find something that has all 3 of these somethings. Anybody want to take any guesses? Lainey?
I'm gonna use the one we just did and then convert the moles to grams.
That is exactly what you have to do. Okay, so molarity is our most useful formula, but it presumes that we have to know the number of moles. So remember, going back to olden days when we had our dark green sheet, you have to remember how to convert grams to moles and vice versa. You don't need to take it out because if you don't want to, because I will refresh your memory. This would maybe be something I would write down on my purple sheet as well. But this is why when I tell you that your exam isn't cumulative, that's really not true. Because this is stuff that we learned at the very beginning. It was still hot in here when we learned this. Okay, so to go from grams to moles, you will divide by formula weight. To go from moles to grams, you will multiply by your formula weight. So this is a thing that we have to do all of the time. So a couple of times actually when you've been taking tests, I've been making up solutions for different things. And so when I see a lab, or if I think most of the times I make up my labs from my own brain, but if I see in my mind that I need a 6 molar NaCl solution, that's nice. Well, how do I make this? There's like no instruction for this. I have to do all of the calculations in my, on my own. And so what I have to do is I have to decide how much of it I need. I have to decide what my concentration is, and that's what I did here. And then I calculate the number of moles, I convert that to grams, and that's how much I know how to weigh on the balance. So you cannot, there's no like scale that measures in the unit moles. We have to be able to convert from grams to do that. Okay, so if we want grams then, but this is my formula, which one of these three things do I not have right now?
Mole.
Correct. So that's what I'm going to solve for first. And so that math is simple. So you should get 0.6. How many significant figures? 3. And my unit is so now every time, especially since like I'm probably not just doing this, I'm like maybe FaceTiming with somebody or maybe I'm listening to music. What I should always do when I get an answer, I should look at my unit and go back to my data table and think to myself, is this what I'm looking for? And my data table will say no. So that's how I know that I can keep doing more steps. Okay, so then I'm going to go back to my purple sheet. My purple sheet is going to say to go from moles to grams, multiply by the formula weight. Okay, great. But what's the formula? So you're going to need to calculate the formula weight for that. It should be 180.18. Okay, so I'm just going to put that number into my work here. You don't need to show work when you're doing calculating formula weight, but hopefully you'll get it right. I guess I don't need this. And so then you'll just do this math. Now, did anybody get an answer? Okay, I'll do it too. I get 108.108. Okay, so how many significant figures should I have?
3
Correct. And what should be my unit?
grams.
And remember, if you're confused about what your unit should be, go back to your data table. How was that? Lainey?
How do you know it's significant?
I'm going to go back to my data table originally. And because this is like really a perfect number anyway, so this wouldn't determine. But if you copied your data table down correctly, that would be where I would go to look to see how many significant figures I needed. And since both of those numbers have 3 it shall be. Any questions about how we got here? Right, I want you to look at number 8. Number 8 is exactly the same as number 9. Yes, ma'am. That's correct. Yep. All right, so you look at number 8, you make your own data table. See if you can get it started. It's just the same as the one we just did. There are two mistakes on the board. Both of them significant figure related. Can anyone find the first mistake? Lainey? It should be at the end, 4.50. Because you need three significant figures in this problem. But then I made another mistake. When I wrote down my answer for the answer here for moles, this number here should only have three significant figures. And while it's not the end of the world to write it down incorrectly, and because I got this exact number here from my calculator, I'm more tempted to write this than 4.500. But this is a good way to get yourself tricked by not carrying like your significant figure work through your problem. Unless you have like a habit in your mind to always go back to your data table to find number of significant figures. Do you have any questions about how I got this number? How do we feel? Okay, good. All right, let's take a short little break. Let's do 5 minutes, and then we will come back and learn the other formulas.
Yeah.
Okay, Rowan, we were just talking about who is in my sessions for Old Lady Crafts, and it's... Ooh. Okay, so let's talk about formula number 5. So when I buy liquid chemicals from the chemistry supply store, they come concentrated. But most of the time we don't need to use them concentrated. And so we have to dilute them so that we can use them. For example, when you buy hydrochloric acid, it comes as 12 molar, which is pretty concentrated. Like if you touch that, it'll hurt you pretty badly. Also, it's also so volatile, it evaporates very easily. Liz, I think you were in here that one day I was diluting some HCl. Because we don't have a proper ventilation unit, it evaporates and it forms chlorine gas, which is toxic. And so it just is so dangerous even to breathe in. If you went up to it and took a pretty big sniff of it, you'd probably die. Yeah.
Friday they had to evacuate the line because something went wrong with the chlorine and it was being released.
Yeah, it's not healthy. So we don't use things as their concentrated form very often. So we have to dilute them. And that's what this formula is for. So your formula sheet does really break this down pretty nicely. And so it'll tell you that your M1s are of your stock solution. The stock, it would be in its most concentrated form. And then the M2, V2 section is for the solution you're trying to make. But it doesn't even actually matter which one you assign to, what molarity you assign as M1 and M2. What matters is keeping those volumes together. So just like when we worked on the titration formula, you'll notice that this is almost identical to the titration formula. You just have to make sure that you're keeping your like things together. Okay, so let's look at number 12, for example. God bless you. Number 12 says, what volume of a 1.25 molar KNO3 solution is required to make 1 liter of a 0.1 molar solution by dilution? Okay, so it says by dilution, that must mean the dilution formula. So I'm going to make myself a little data table. The M, capital M here stands for molarity, and then the V is for the volume. It doesn't even matter what unit volume is in, it just has to be the same unit for both. Okay, so it says what volume? So right away I'm going to say that V1 is question mark. Why did I choose that? Because it was the first thing I saw? No rhyme or reason. But then I'm looking for the words of or of a. That's what's going to connect the two numbers and like mean that they have to have the same like little subscript as their variable. So of a 1.25 molar, that's how I know what M1 is. Now process of elimination can tell me what the other two things are, but I'm going to go through it in the same way. So now we've got 1 liter, and that's the only other place I can put a volume because that is what liter is. And then it says of a 0.100 molar. So that's how I know that those two substances or those two numbers are just describing the same solution. So you're going to look for the words of or of a. And that's what's going to connect an M and a V together. Okay, so if that's the case, maybe before this in your notes or maybe on your purple sheet, do you want your formulas? Do you want your algebra? Okay, so if you solve for M1, it'll be, M2V2 divided by V1. If you're solving for M2, M1V1 divided by V2. To solve for V1, M2V2 divided by M1. And for V2, M1V1 divided by M2. So if you look carefully at this, you could pick out the pattern. But perhaps you just want to have them written down in a tidy way on your purple sheet. God bless you. Okay, so now back to this problem here, number 12. I'm just going to make it a little bit smaller so I can keep both these things on here. Which one of the formulas should I use? Well, it looks like I'm looking for V1, so that means I'm going to have to select this formula. Does that make sense, like knowing what formula to pick? Because if it doesn't, that's like we're in a bad way then. But knowing what formula to pick is that's a real life skill. Did I ever tell you guys about the time I got a 21% on a physics exam in college? It was a BC. Do you know how I got those 21 points? Writing formulas down. Did they mean anything? Nah, not to me. But it was a BC, so that means I was slightly above the average. So a while back, Miss Nichols was talking to somebody and she was saying about how, like, oh, maybe you should try for a higher score. And I was like, Miss Nichols, scores are relative. I once got that 21%. And she didn't believe me. She thought I was just like being weird. But no, not that time. Okay, so I put my numbers in. Now, this is where, like, this part here is easy if you've done a neat job of writing this down. Like, if this part is tidy in your work, this part should be a piece of cake. And so I get 0.08 as my number. How many significant figures should I have? God bless you. You should have 3. How many do we have?
1.
Only 1. And then what's my unit? It should be liters. How do I know that? Well, I'm going to look back at my data table, and my data table says I'm looking for volume. And since it doesn't like tell me a unit in here, I'm gonna have to do a little bit of like detective work. And so I'm gonna then look over here at my problem, and I'm going to see that, oh, both of my big M's canceled, and this was the unit I had left. That should be the unit I report. That's why it's so important to write those units next to the numbers, because it helps you when you get to this bit here. So what does this mean? If I wanted to make this solution in the lab, I'd need 80 milliliters of my stock solution and to dissolve it in a full liter. 80 milliliters is a really small amount. It's like almost 3 of those shot things that, God bless you, that you would only take of like, you know, medicine. Okay, what do we got? Let's do one more example of this. I would like to do number 11 because 11 is the trick question. Number 11, you have to use your noodle and you have to read. And I know that's a hard thing because I sometimes also struggle with, you know, reading basic instructions. All right, so 11 says, if 300 milliliters of water is added to 200 milliliters of a 0.5 molar solution, what is the molarity of the resulting solution? Okay, so what does it mean when water is added to something? It's diluted, right? So that's how we know to use the dilution formula. Okay, so if I know to use the dilution formula, I know to make my list of 4 variables in my data table. All right, so let's try to make some sense of this. The first thing on my list is molarity. And there's only one number given with a big M in this problem. It's the 0.5. So maybe I'll just start here. So what would be V1 though? In order to figure out which number goes with that 0.5, I need to look for the words of a. And so I see of a 0.5, and the number that comes right before that is 200. 200.0. And then M2, it says, what is the molarity? So that would be question mark. But what's V2? Well, a lot of times we just want to think about, oh, word problems are so confusing. Let me just write the numbers down. And so the only other number I have in this problem is that 300. Well, you'd only be half right because it says in your problem that 300 milliliters was added to the original amount. So how much do you really have at the end? You really have 500. So the moral of this story is sometimes we have to read. Okay, so then which formula will we choose? The one that solves for M2. And now you should be able to put your numbers in there, and your math teachers probably call that plug and chug. Have you ever heard that? Did they ever say that? Oh. So I had a math teacher very much like Mrs. T when I was in high school. And that was one of the things that she would always say, plug and chug. All right, you solved your formula, plug and chug. Okay, Mrs. Poole. Her name is Mrs. Poole. But this woman was like the greatest teacher. I remember everything she taught me. And this was some minutes ago. Alrighty, so what should be my answer? My brain doesn't want to do this in my head. I get 0.2. for my math? How many significant figures should I have?
3.
Ah, we have a disagreement. All right, so let's look at our data table. 3, 4, 4. The smallest of the numbers is 3. And what's our unit? Big M. These questions are pretty easy if you can read. All right, so then we just have one more type of solution calculation to do, and it's the normality one. And there are only a couple of problems about normality. They're at the end of the packet, I think. There might be some on page 5. But the last way to calculate concentration is normality. And normality is used only for acids and bases. Now, we've used it before, but we used it in a way where we just didn't know what it was. So normality is actually probably the simplest of the formulas, but you have to know what these words mean. Ladies. So your formula sheet says number of equivalents times molarity. Okay, well, we know about molarity already, so we're fine with that. But what the freak is an equivalent? An equivalent is really like how many powers of acid or base do you have? So it really is defined as either the number of H's if you have an acid, or the number of OH's if you have a base. So how do you know that? It's literally by looking at the formula. All right, so let me give you an example of some acids and bases. Okay, so here are all acids. Let's talk about how many equivalents. The number of equivalents has to be a whole number because there can't be like a 0.5 of a hydrogen. So in this example, how many H's are there? That's the number of equivalents. How many H's are in HCl? HI? H2SO4? It's literally in the formula. All right, so then we can do the same thing for bases. So how many equivalents are in sodium hydroxide? In calcium hydroxide? In lithium hydroxide? In aluminum hydroxide? So you just multiply that number by your molarity, and that's it. All right, so let's do an example of this. Let's look at number 28. I'm just going to try to fit it in right here. What is the normality? So big N equals question mark of a molarity equals 1.85 H3PO4 solution. Okay, so now how many, usually I abbreviate equivalents as EQ because I don't want to write the whole thing. You can do the same. Okay, so how many equivalents are in H3PO4? So yes, it's easy. Yes, you still need to write the formula down. So write your formula down, no problem. And then 3 times 1.85. And then your answer magically changes units to big N, which like we say is normal. What do you get for an answer? Oh no. I got 5.55. Your unit is big N. Well, I think that that's as complicated as it gets. Do you need to show your work for those? Yes, you do. But let me just make sure that that is indeed as complicated as it gets. Indeed. All right, you should be able to do every one of these on here now. I had planned to do a lab on next class, a Making Solutions lab, so I'm going to hand that out to you now. I'm going to hand it out and then I'm going to explain it because it seems like there's a lot of work here, but it actually is just like the background I had to do because we're just going to practice making solutions. Okay, so does it say on here? What's happening about there, Joseph? Yeah, that sounded like Mr. Mack.
He did just walk past.
Okay. What is going on? That's too early in the week for this. Okay, so what I want you to do to prepare for this lab on Wednesday is to read this paper and then make a table like this in your notebook, in your lab notebook. There are 2 rows on this table. Just start with 1 for now because I have to decide what solutions I want you to make. And I will, and so like part of your work in your lab group will be to do the calculations together. And so I don't want to give that to you in advance. So just read through this, please, and then get a data table like ready for yourself. Do you need a procedure? No. You just need a data table and a place to make calculations in your lab notebook. So the really only thing I want you to do is to read this. There is some terminology on here that I'm not going to go over, like the term QNS. I want you to read about that in here, because you'll need to know what that means when we get to lab. It's pretty simple, but it's one of those things that you just have to know the jargony terminology. This homework is not due until, wait, what?
It said this due Wednesday.
It does say that. I would like to prayerfully change that to next Monday. I don't need it until then, and so I might as well give you an extra minute. Yeah, it's a little bit lengthy, so please change that on there as well.